Right then, Cloud Gurus, this is going to be a short one, I hope. Now, services are powerful, right? And if we look at a quick example from the sample apps YAML files, we can see here there's a field in the spec section called type. Well, that's because there's different types of services that behave slightly differently. The main ones are cluster IP, node port, and load balancer. Now, as we take a quick look at each one, right, it's really important not to lose our focus on the fact that they all do essentially the same thing, right? Provide that stable networking abstraction point for a bunch of pods. I guess the reason for the different types is mainly use cases. So, cluster IP is the default and it's the most basic. Now, that means if you see a manifest file that doesn't actually specify a type, you're going to be getting cluster IP. And it's really easy, right? As the name suggests, it gives a service its own IP address that is only reachable from within the cluster. So cluster and IP makes sense, yeah? Well, building on top of that, we've then got type node port. Now then, node port services, they also get a cluster IP, so you can still access them in that way. But as well as that, they enable access from outside of the cluster by way of a cluster-wide port. So, each service with type node port gets its own cluster-wide port, and it's accessible from outside of the cluster by taking the IP address of any of the nodes and then appending that cluster-wide port or node port value to the end. So the picture here is showing a 4-node cluster, yeah? Each node's got an IP on the node network, yeah? Well, we create a node port service that generates this kind of semi-random port that when you append it to the IP of any of the nodes in the cluster, boom, you're going to reach the service. And then obviously the pods that it's serving, yeah? Now, the default range of ports that a node port value can come from is between 30,000 and 32,767. Though, you can change that with this kubeAPI server flag here, but honestly, it's not something I've ever done myself. Something I have done though is specify particular ports for a node port service. You know, like if you've got a particular port that you need it to run on, well, just do that in your service manifest file with the node port field here. Though, I will say this, right, anything that you specify here, that's still got to come from the range of configured ports. So again, by default, that's 30,000 to 32,767. And it can be TCP and UDP, yeah? The default's TCP. But that's node port, right? Access a service via a combination of a node IP and then this cluster-wide port called a node port, and it works from inside and outside the cluster. Bingo. Well, the third type is a load balancer, and this is for if you're deploying in the cloud, because it provisions a cloud-based load balancer and then integrates that with the service on your cluster. Well, obviously, to provision a load balancer on a cloud platform, your cloud platform has to support load balancer creation and config via a public API. And obviously, Kubernetes has to know it and support it as well, right? Now, I've done this on AWS, Azure, and Google Cloud, and it works a treat. You get an internet-facing load balancer that proxies traffic to your service, usually via a node port service, right? But you don't have to create the node port service. Kubernetes does all of that. So, now, just to be clear, some cloud platforms configure the back end of their load balancer to forward traffic to nodes in the cluster by way of a node port service. So that means they create a node port service and then they balance traffic coming in across all nodes in the cluster on the node port port. The node port port. I like that. Now then, you'll occasionally see implementation differences for load balancer services, right? Like, I think unless things have changed, I don't think Google Cloud actually needs to create a node port service, but AWS and Azure do. But you know what? These are implementation details. They've got zero impact on the overall functionality of the load balancer service. But I hope you get the picture. You get a cloud-native, public-facing load balancer that's configured to connect to your Kubernetes service on the back end. Now, we'll see it in a minute, and I think you'll love it. But, real quick before we do that demo, let's take a few minutes to explain the service network.